Hello everyone. So let's now solve practice assignment week 10 question number 3. Which of the following are critical points of the scalar valued multivariable function for this? So we know that at the point of critical points, both the partial derivative would be 0. So we can find the partial derivative as with respect to x, 6x square minus 6y, and with respect to y it would be 6y minus 6x. And we can set them both to 0. Now this would be our equation 1, this would be equation 2. So from equation 2, that is 6y minus 6x equal to 0, we will get y equal to x. Now we can put this result in equation 1. So on putting y equal to x in equation 1, that is 12x minus 6x square minus 6y equal to 0. So this was our equation 1. If we replace this y with x, we will get this. Now if we simplify it, we will get minus 6x square plus 6x equal to 0. That is 6x square minus 6x equal to 0. Or in general, we can take x common or divide both sides by 6, and taking x common, we will get x into x minus 1 equal to 0. So x is equal to 0 or 1. And as y is equal to x, so we will get y also to be 0 and 1. So the critical points can be, if x is 0, that means y would also be 0. So this would be one critical point, that is, and if x is 1, in that case y would also be 1. So that this is another pair, 1 comma 1. So option 1 is correct, 2 is correct. Let's start. So let's now solve practice assignment week 10 question number 6. Find the number of points where the tangent plane to the function at the point is parallel to the xy plane. Now we have seen this before also in question number 2, that when our tangent plane is parallel to the xy plane, all the partial derivative, that is both with respect to x and y, and also the directional derivative, would become 0. So that means the points where the tangent plane would be parallel to the xy plane, at that point the partial derivative with respect to x and y would be 0. So if we calculate the partial derivative with respect to x for this function, we will get is 3x square plus 6x minus 9, and with respect to y, 3y square minus 12. Now, if these, at the point where these two will become 0, are the points where the tangent plane would be parallel to the xy plane. So we just have to make them 0, and this would be our equation 1, equation 2, and if we see from equation 2, we'll get 3y square is equal to 12, y square is equal to 4, and y is plus minus 2. And from equation 1, what we have is 3x square plus 6x minus 9 equal to 0. And if we solve this, we'll get x to be 1 and minus 3. So the points that at which the tangent plane would be parallel to the xy plane are, if x1, we can take 1 2, 1 minus 2, and minus 3 2, and minus 3 minus 2. So these are the points on which the tangent plane would be parallel to the xy plane. Thank you.